Hey, what's happening, guys? Welcome to Fire Racer Workshop. My name is Lucifer, and in today's video, I'm gonna be showing you the full subtractors. Now, this is the circuit that I made for the full adders and the full subtractors. So, in this particular circuit, both these things are integrated. So, right this side right here, this is the full adder side. This side right here, this is the full subtractor side. Likewise, these two LEDs are for the adder, these two LEDs are for the subtractors. Now, this LED right here, this represents the difference, and this one represents the borrow. Difference and borrow. Likewise, there are three inputs to this full subtractors. I'm not going to be using the full adders as I've already covered it in my previous video, so do check that out if you want to see the full adders. So these are the three inputs for the full subtractors. Now the yellow one right here, the yellow one, that's the input number A, input A. White one, that's the input B. Violet one, that's the input C. Now let's just simulate this circuit. I'm powering it with my lab bench power supply that is set to 5 volts, and you can see the current draw of the circuit is 0.02 ampere, so that's 20 milliampere. Pretty insignificant current draw, I'd say. Now, so let's just simulate this circuit. Let's just test this out. First of all, what I'm gonna do is I'm gonna place this yellow wire right here. I'm gonna place it at 1. So let's just make it high. Let's see what the difference is. You can see the difference is equal to 1, and that's actually correct because the difference should be 1 because this is a positive input. So the A input, so the A input is considered to be positive. So there's 1 minus 0, that's equal to 1. So the difference is 1. Let's just place another input. So let's just place this B input at 1 as well. According to the truth table, this LED should not light up. None of the LEDs should light up. And that's the case. None of the LED is lighting up. So the difference of 1 minus 1, that's equals to 0. So which is represented by my LEDs turning off. So this is a 0 state. I mean, the difference is 0. Let's just place this B input at ground again. Now let's just place this C input. The violet one is the C input. Let's just place it at 5 volts. Again, you see the LEDs just stop lighting, so LEDs just turned off, which represents the output is 0. Now let's just place all of them at ground, and let's just play with this B input now. Now if I just place the B input at high, so that's 5 volts. I'm just providing 5 volts with this rail right here that is connected to my power supply as 5 volts. So if this is at 5 volts, you can see that it's an equivalent of -1, which is borrow 1 and difference 1, which represented correctly by my subtractor right here. So this is the correct representation of the output by my LEDs. If I just place the B again at ground, and let's just place the C input at 5 volts or at 1, at high position. Let's just place the C input. Again, you can see both the LEDs will light up because this is an equivalent of -1. Now, if I place, again, you have already seen, if I just place A also at high, both the LEDs will just turn off. Now, what will happen if I place all the three inputs at high? Let's just see. Again, you can see this is a representation of -1. Why is this a representation of -1? Because 1 minus 1, that's equals to 0, but here we have another -1, which is -1, which is represented at the output when both the LEDs are just turning on. So this is all for the video. So therefore the truth table of this particular full subtractors is verified. Thank you all for watching.